In chapter 6, we're going to look at some advanced and useful techniques in at risk. So the first one we're going to look at is called advanced sensitivity analysis. Here we will revisit the movie pass case, and the advanced sensitivity analysis is pretty much we've used risk sim table to set up different scenarios. Those are basic level scenarios. Whereas here in advanced sensitivity analysis, we can take several input variables and build more complex scenarios, and then we can run the simulations for all those scenarios. So set up scenarios for each uncertain input variable, and then run the simulation and review the results. So that would be one. The first one, we will use movie pass as the case for us, and then we'll use the same movie pass case and do what is called stress analysis. Stress analysis is when you take the input variables. So the input variables, say for example, input variable has a normal distribution. So normal distribution means most of the time the values will be kind of in the middle. But there are some extreme situations where it may be in the tails. So what will happen under those extreme situations? If the input variable turns out to be those extreme cases, so what will be the pattern of the output results? So that's what stress analysis is. So run simulation model for extreme values of uncertain input variables, and we'll also look at tornado charts versus spider chart. Tornado chart is more is not detailed enough, whereas spider charts will give you more granular information about the output variables. Then the second more advanced topic is non-parametric probability distributions, where none of the theoretical probability distributions that at risk offers suits your needs. So in that case, you can set up, in the case of discrete input variable, you can set up a frequency distribution under this functionality called risk cumul, and at risk will generate random values from that distribution. A similar functionality for continuous variables, input variables, is risk general. So we'll talk about that a little later. Then there is another functionality called risk splice. So that would be very useful when the probability distributions are kind of different at different input ranges. Okay, so if a distribution has more than one mode, so 2 or 3 modes, or it has some strange shape, so you then try to fit probability distributions for different ranges of the input variable values. So you'll have one probability distribution from A to B, another one from B to C, another one from C to D, for example. Then you stitch them together using this risk splice, and let at risk generate random variables from this spliced together compound probability distribution. So we'll look at that. Then we look at a concept called frequency and severity of adverse events. Okay, and the typical case here is an auto insurance case where we have frequency of events. So you insure a group of people and there are some claims. Okay, so that's your frequency. And then I have more examples of this in the actual lessons. Then for a given claim, okay, what is the amount of claim? So that's your severity. Okay, frequency and severity, and how do you simulate these? So you don't want them to be independent. So you don't want to simulate the number of claims separately and then your amount of claims separately. So if you do that, then in effect what you're saying is each and every one of those claims will have the exact same claim amount. So these two are to be done independently. So you have to. So if you have 10 claims, you have to simulate 10 different claim amounts. So how do you do that? So that's the so you use what is called risk compound to simulate separate severity for each event occurrence. So, and there is another feature also, so that is uncertainty of parameter values. So you have probability distribution parameters for normal distribution, mean and standard deviation. What if the mean and standard deviation themselves are not are uncertain? So you don't know what the mean and standard deviation are, and so you have uncertainty of parameter values, and we want to incorporate that, study that. So we will look at that. And then we will look at Bayesian analysis. And here the case study that we're going to look at is one where we have two studies of adverse outcome from pregnancy due to Zika infection. Okay? And we will look at two different approaches, what is called frequentist approach, where we ignore any information, additional extraneous information, relevant extraneous information that may be available. You look at just the study that you're looking at. Okay, so non-Bayesian. And then you have a Bayesian approach where you revise the probability with relevant prior information or relevant general information that's outside the current study. So we look at these two comparisons under the rubric of this case of adverse pregnancy outcomes. And then within that, we'll also look at the risk general, say like risk discrete risk cumul that we looked at for discrete input variables, and here risk general for continuous distribution of empirical values.